Hello friends, welcome you all on the lecture on model analysis and similitude. So the points which we are going to cover under this model analysis and similitude, those are nothing but first point will be related to the model analysis. So under that model analysis, what is meant by model and what is meant by prototype. Second point, or in the same model analysis, second sub point will be why there is a necessity of model analysis. Then third sub point will be what are the different advantages of dimensional and model analysis. Then second part of this video is nothing but the similitude. What is meant by similitude? What are the different types of similitude? So basically there are three types of similitude. Those are nothing but geometric similarity, kinematic similarity, and third one is nothing but the dynamic similarity. So first point is nothing but what is meant by model and prototype. So here in this picture you are observing that there is one actual, or there is one bigger one car and there is one smaller car. Suppose I want to manufacture, or I am having the unit, or I am having the plant in which I am manufacturing the car. So it is not possible to, after designing the car, it is not possible to directly manufacture that car. So first of all I need to test, or I need to predict the various behavioral parameter of that car. So for doing that I have to make a small scale replica of that actual car. That is nothing but I have to make one smaller car, and various tests I need to perform on that smaller car, and after performing the various tests on that smaller car I have to predict the behavior of that actual car. So whatever this actual car is there, that is called as a prototype. And here to analyze the pattern, or to analyze the behavior of that actual car, whatever car I have made, that is called as a model. So the definition of model is nothing but this small scale replica of actual structure, and prototype is nothing but the actual structure or machine is called as a prototype. So here it is not necessary that model should be small all the time. Model should be smaller than the prototype. Sometimes whatever actual machine or whatever actual component I have to manufacture, that may be in the smaller size. So to predict the behavior of that, or before manufacturing, to predict the behavior of that component, I may manufacture a model which will be larger in size. So it is not necessary that model should be smaller than the prototype. Sometimes it may be larger or larger than the prototype. So why model analysis? So we are knowing that there are various hydraulic structure such as dam, spillways, or there are various hydraulic machine such as turbine pump. So while manufacturing or while constructing those various structure, hydraulic structure or hydraulic machine, I cannot directly manufacture, or I cannot directly construct that hydraulic structure or hydraulic machines. So before actual construction or before actual manufacturing of that hydraulic structure or hydraulic machines, I have to prepare one model, and on that model I need to take various tests, and with the help of that various tests which we are taking on the model, I have to predict the behavior of that actual machine or actual structure. And after predicting the behavior of that actual structure or actual machine, if I am getting the desired output, then and then only I have to actually manufacture, or I have to actually construct that hydraulic machine or hydraulic structure. So for that purpose we require the model analysis. So in the last video we have also seen what is meant by dimensional analysis, Rayleigh's method of solving the problem, or Rayleigh's method of dimensional analysis, Buckingham pi theorem. So here we are going to see what are the different advantages of dimensional and model analysis. So first advantage is related to the dimensional analysis. So we have seen that by using the dimensional analysis we are able to perform, or sorry, we are able to uh, correlate the various physical parameters, or we are able to find out the various physical parameters which are affecting on that model or which are affecting on that prototype. So here by using dimensional analysis, a relationship between various variables influencing the flow pattern is obtained, which will be helpful for conducting the various tests. Then advantage of model analysis is nothing but, here model analysis we are performing before actually constructing or before actually manufacturing a prototype or actual structure or actual machine. So with the help of model analysis we can predict, or in advance we can predict the behavior or performance of that hydraulic structure or hydraulic machine with the help of model analysis. So the main advantage of model analysis is nothing but, here as we are performing or as we are getting the in advance prediction of performance of that hydraulic structure or machines, we can find out the alternative designs, and with the help of that alternative design, or by comparison with the help by comparison or by comparing the various alternative design, finally we can select the most economical and safe design for the actual manufacturing or actual constructing of that hydraulic machine or hydraulic structure. So those are the various advantages of dimensional in model analysis. But main point, so whatever those various advantages are there, that means whatever prediction we are going to take after, or whatever prediction we are going to predict after model and dimensional analysis, so the main point is that whatever test we are performing on the model, so for obtaining the useful information or for obtaining the various parameter or performance in advance, so that will be correct only if there is a complete similarity between the model and prototype. If there will not be the complete similarity between model and prototype, then whatever result we are obtaining by testing the model, that will not be the corrected one. That means whatever prediction we are taking or whatever prediction we are predicting based on the model analysis, that will not be corrected one. So that will be corrected one only if there is a complete similarity between model and prototype. Now similitude and its type. Similitude is also called as a similarity between model and prototype in every respect. So similitude, it is defined as a similarity between model and its prototype in every respect, which means model and prototype have similar property or are completely similar. So as I have already told, there are basically three types of similarity which must be exist between model and prototype. Those are nothing but, first one is the geometric similarity, second one is called as a kinematic similarity, and third one is called as a dynamic similarity. So one by one we will see all the similarity. So geometric similarity, as the name itself is indicating the geometric similarity. Similarity means there should similitude means there should be the similarity between model and prototype in every respect. So as the name indicates geometric similarity, so geometric similarity means similarity in shape. Now similarity in shape means, here I have shown one picture. Suppose this is our actual product which we want to manufacture. So before actually manufacturing of this product, we have to make one small scale replica of that actual product. Actual product will be called as a prototype, and the small scale replica of this prototype will be called as a model. So here, if this is the length of that actual product, if this is the diameter, if this is the area or volume of that actual product, the various flow property, that means here if surrounding to that actual product there is one fluid, so these are the velocity acceleration component at various points in that actual product. So here also in that in that model also here we have shown the various velocity, acceleration, as those fluid as that fluid is flowing surrounding to that actual product, that will act the various forces at various point. So those various forces also we have shown on the model as well as prototype. So here in case of geometric similarity, we have to see the similarity of the shape. That means here we are going to say that whatever model and prototype are there, this is called as a prototype, this is called as a model. So we are going to say that whatever model and prototypes are there, those are in geometric similarity if the ratio of all the corresponding linear dimensions of model and prototype are equal. Linear dimension means length of model, length of prototype, diameter of model, diameter of prototype, then width, area, volume. So those are called as a linear dimension. So if we are getting the ratio of all the corresponding linear dimensions in the model and prototype are equal, then and then only we are going to say that geometric similarity exists between model and prototype. So here formula is LP upon LM is equal to BP upon BM is equal to DP upon DM is equal to LR, whereas LP is called as a length of prototype to the length of model is equal to BP called as a width of prototype to the width of model, diameter of prototype to the diameter of model is equal to LR. LR is called as a scale ratio. Similarly, if I am getting AP upon AM, that is area of prototype to the area of model is equal to is equal to LR square, called as a scalar ratio square, and PP upon PM, that is nothing but volume of prototype to the volume of model. Then and then only we are calling PP upon PM is equal to LR cube. Then and then only we are going to say that whatever model and prototype are there, those are under geometric similarity. So geometric similarity means similarity of shape. That means all the corresponding linear dimension, that is ratio of all the corresponding linear dimension such as length, diameter, width, area, volume should be in the same ratio in case of model and prototype. Then second type is called as a kinematic similarity. So kinematic similarity is called as a similarity of the motion. Similarity of motion means if the ratio of velocities and acceleration in the corresponding points in the model and prototype are equal, then and then only we are going to say that whatever model and prototype are there, those are under kinematic similarity. So in the previous diagram we have seen that whatever fluid is flowing over the model and over the prototype, that fluid are having various values of the velocity and acceleration at the various point. So if I am going to take the ratio of various values of velocities in the prototype and various values of the velocity in the model at the corresponding points, and if I am getting the same ratio called as a velocity ratio, then I am going to say that there is a kinematic similarity exists between model and prototype. Similar to the velocity, if I am getting the acceleration, ratio of acceleration in the prototype to the ratio of acceleration in the model at the various corresponding point equal to AR, that is called as the acceleration ratio, then also I am going to say that whatever model and prototypes are there, those are under kinematic similarity. So here, as velocity and acceleration are the vector quantities, so here we are knowing that in case of vector quantities, the magnitude as well as direction of that velocity and acceleration are playing an important role. So in case of complete similarity, not only the magnitude of that velocity as well as acceleration at the corresponding point should be same, but also the direction of velocity and acceleration at the corresponding point in the model and prototype should be parallel. Then and then only we are going to say that there is a kinematic similarity. Then third one is called as a dynamic similarity. So dynamic similarity means the similarity of forces. So we are going to say that there is a dynamic similarity between model and prototype if the ratio of forces at the corresponding points in the model and prototypes are equal. So here in this diagram which we have seen, so in case of prototype as well as in case of model, as fluid is flowing surrounding to that prototype as well as model, so that fluid is acting the forces at various point on that prototype as well as on the model. So here if we are going to consider any points or if any points in the prototype and the corresponding point in the model, and if I am getting the ratio of forces at the corresponding points in the model and prototype are equal, then I am going to say that there is a dynamic similarity. So as force is also vector quantity, so not only the magnitude, along with magnitude the direction of force at the corresponding points in the model and prototype should also be parallel. That means here at this point, if the force is acting towards this direction, so in case of model also at this point the force should act in the same direction. That means that should be parallel. Then and then only I am going to say that there is a dynamic similarity. So similarity of forces. So if I am considering Fi as a inertia force, Fv as a viscous force, Fg as a gravity force, and if I am going to take these various forces at the various points in the prototype and at the corresponding points in the model, and if I am getting the ratio of all those forces in the prototype and model is equal to same, then as well as whatever these various forces are there, those are acting in the same direction, that means those are parallel, then I am going to say that there is a dynamic similarity. So this was the topic, or this was the presentation related to the model analysis and similitude. So thank you.